Hi, everyone. Today, I want to talk to you about how to simplify the use of Istio for your R&D organization, or in other words, how all your developers can use the Istio security and networking features without really knowing Istio. So a few words about me. My name is Isan Rivkin. I work at SimilarWeb as a production engineer. This means I love infrastructure and platform developing. I like Kubernetes, developing in Rust, in Go, and generally everything about distributed systems. You're welcome to follow me on GitHub and maybe collaborate with me on projects, or follow me on Twitter. And if you do follow me, so it will be you and my girlfriend. So thanks for that. I work at SimilarWeb. We're a data analytics company. We provide metrics about the world. We run with microservices. We all operate on AWS, and we used to have Nomad as our orchestrator. We're moving everything and almost finishing to AWS Kubernetes EKS. We use an active-active setup, which means we have cross-region deployments at the same time of Kubernetes. We handle about 100K of RPS, and we process about 10 petabyte of data. And you're welcome to look up on our SimilarWeb GitHub account. There's a bunch of open source projects that we actually maintain and develop. Some metrics and also why we chose Istio. So at first, I looked up Istio and its other two biggest so-called competitors online to see some popularity, to understand who uses what. And actually, the findings are interesting. We can see here over time, the graphs of the blue is the traffic of Istio. And we can see that during Corona, during COVID, there was a big increase in the Istio usage, or actually visits to the website. And here we can see another increase. I guess it's related to the fact that IstioD was merged and the new releases are awesome. And below this, you can see that the competitors have a very small market share in it. Also, I picked the top 5 countries that actually use service mesh and those 3 service meshes. And by order, you can see that in China, Istio is actually the most popular, then United States, India, Brazil, and Poland. And the other 2 services have a very small market share. And this is a big reason to use Istio. Also, it's not enough. So we needed the traffic access control to our pods in terms of security. We needed awesome networking capabilities to stop reinventing the wheel, like traffic mirroring. And we wanted distributed tracing, which we already had, but we kind of invented the wheel again and again. So Istio is all in one, which we very like, and it's easier to maintain when you get the grasp of everything. Now, the problem. So, okay, we get Istio, we learned it, we love it. What now? Before Istio, we used to work with Nginx ingress controllers. And this is so simple. You don't need to know much. You just add 2 annotations, right? Maybe even less to your ingress. And there you go. You have this ingress of Nginx, and you get SSL redirects, and you're done. You don't really need to know too much. And when we move to Istio, this is kind of like how a YAML file of an Istio deployment would look like. And there are many things. So there's the basic stuff like config, service, and deployments. And then there's service account, because you want to have those authentication and authorization in place and identity. You would create a virtual service to define your destination rules better. Maybe you'll add an envoy filter for some HTTPS redirects or some clever pattern matching. You would have to connect it to the correct gateway, and all of this is provisioned with the Istio operator. And it's complex. There's a big learning curve. We wanted to prevent all those copy pasting of developers taking the same charts everywhere. And we wanted to have security in place with deny by default, deny all. And you need the correct ingress routing. So how do you make sure that internal service is not exposed to the external world? And how do we get the visibility? Maybe my sidecar is broken and maybe my application is broken. And in the end of the day, the goal is to always enable the R&D, move as fast as possible to deploy to production as easy as it can get. So quickly we realized implementing and integrating Istio is not enough. We need to take a step further. And we decided to go with the idea of abstractions. We wanted to abstract the business needs from the technical needs. So if a service in terms of the business needs a high SLA, but technically it means it's need many replicas inside Istio, those things doesn't have to be interconnected and we can abstract them. So first what we did, I'll show you a little bit about the architecture we have of Istio in our organization. Yeah, doesn't matter. It's a black box, and this is what I want you to take out of this. To use the abstractions we made, you don't really need to know too much, which is a good thing, while you have the best practices. So we leveraged Helm to create the Helm building blocks, small charts that can be used by another charts via the dependency feature, and kind of compose a bigger stack. So for example, we created security chart that have all the best practices in place and abstracts everything for you. You would add this inside your chart, kind of like a one big umbrella deployment. And in your values file, you would just specify, so those are the values for this dependency chart. For example, this one allows Istio Ingress Gateway access for get methods with some namespace. After we have this, it's not enough because developers don't love to write too many Helm charts, and still it gets complicated to configure everything. So we created those, what we call application chart. The biggest one is the common services chart, where everything is kind of possible. So it's everything in terms of lists. You can create lists of deployments, lists of stateful sets, lists of everything. And the values YAML of this chart exposes outside everything in a non-Istio language. So you would pass an array of deployments, and you would have an API object, an UI object. Maybe you need some stateful sets. And the terminology would be like just security configuration, ingress, service config, and it's all encapsulated under one umbrella, as I said. But it created a new challenge. So now the values file of this thing is very big, especially if you have more than one deployment. You need to copy all those configurations again and again and again for each of the deployments you have. So we created this idea of a Helm generator, right? So we wanted to prevent the copy pasting of values YAML. We want people to use precise configuration for security and resources and networking. And we want people with zero to very little knowledge be able to deploy quickly. So we created a questionnaire. And basically, it's a UI that generates the values for you. So we would ask you on a web page, you just go and say, okay, so I want maybe a production cluster. So we would configure 3 replicas or more. The SLA is high, so we would make this cross-region deployment. You would pick a cluster, a region, and most of the stuff would be configured here. The next step is kind of advanced stuff. Maybe you want some environment variables to be added. Maybe you want to mount with the config map to your container some configuration. So here you can pass a YAML, a JSON, whatever, container arguments, everything you need. Here, in case the defaults are not good, you can tweak the how you want to update and what are the health checks. In terms of resources, you would configure everything here, the sidecar and your containers as well. And here comes the Istio abstraction part and the ingress abstraction part, which is very important and powerful because you don't really need to understand things. What you do need to know is you select if you want your service to be externally or publicly available to the internet, maybe only internal, maybe both. You select if you need SSL redirection, and maybe you have some custom DNS you want to add with some routes, so you would put it in here. And then you get the advanced settings of a virtual service. Maybe you want to have different destination rules based on your service or some custom header rule. So you would configure it in here. And then there's the authorization part where you can get into advanced there and say things like enable all the namespace services I'm running it, talk to me, or enable all the services in my current chart to talk to each other, force MTLS, etc., etc. And in advance, you can pick some specific services. Maybe you want them to be able to talk to you. Basically, what we do behind the scenes, we configure all the service accounts with their full names and create all the authorization policies and authentication together. And based on the prior knowledge we have on the context of the architecture of which cluster you run in and all the names and the namespace structure, we kind of configure it all behind the scenes with the correct ingress to the correct gateway and the virtual service. And at the end of the day, you get this button where you can already create a pull request to your repo, and the values file will be there. If it's cross-region, so you would have, for example, one for each region already configured. And this is how you start up. Just to summarize, We had this issue of Istio being awesome but complicated, so we created building blocks for security and traffic. We added application chart so developers can move much easier with those building blocks, and expose the Helm generator so you can easily create precise configuration for your app and very fast. And thank you very much. I hope you enjoyed it. I was Isan.